So maybe we should continue. Yeah, so we talk about sampler and estimator. We did a lot of sampler, and for the last time, we start to experimenting code on estimator. So let me open this notebook. Right, so I commented that in the sample state vector sample, this is V2, you need to use measure. So this is if you measure all, and then you could also specify your classical register's name, and you can use that. Let me see. This is the circuit. We quickly go over this. If you use sampler, this is sampler. And this also uses basic simulator. And you also have state vector sampler. You have circuit. This circuit is 2-qubit, really trivial automa and nothing. So this will be plus and 0. So you know the results. If you run that, so this is still sampler. This is still V. I think this is still V1. Right? There's a warning here. Samplers. This is V1 version. So you have shots. And simulator, you can also run the circuit. Job simulator dot run, and this is sample dot run. So you get results like that. So we know it's 0001. And for the sampler, oh, I should write sampler. Okay. You need to correct the code because let me correct it here. There's a typo here. It should be sampler. And simulator, oh, sampler, and then just sampler. Okay, so yeah, so I think sampler you still need to use. So I need to correct this. This does not work. In sampler, you need to use result, 0, data. So we will need to use 0, result, 0. Let me check. Result 0 data. Let me just copy this. It counts. Tribute results not defined. Oh, I already have results, so I don't need to read results. Result is not subscribed. Okay, so there's some issue. Oh, this is correct, right? I I copied the wrong to the wrong one. This is it counts. This is for the simulator, and this is for the zero data get counts. Yeah, okay, finally worked. You could also use zero, I think. Oh no, I use one and zero. Okay, this is still using this. Okay, so this need to be corrected. So the code that I have there is because I use the simulators, that's why. It's good that we went through this. But you can check what's the result. Simulator. So they're slightly different. Yeah, so last time I said the same because I was using the wrong code. So they're different. The sampler has a primitive result. Okay. It's good that we corrected here. Sampler result 0. Because there's only one circuit. If you use one, then it will not be correct because you have only one circuit. So that's the result. And in order to get that, you use that data. And that data you also have to measure. So if you print the result and then layer by layer, you roughly know what you get. And up to here, these are results, data there. So usually we have get counts. Okay. Simulator result equal to this. But you don't get it by saying result. Let me see. There's also result. You can get it by looking at the simulator data and then experimental result shots data. So probably you can still get like this, I suppose. No. So list has no attribute. It's a list. It's already here. So it depends how you retrieve this. You need to look up the dictionary, the documentation. But we know we can use. How do I close this? Oh, how do I close this tab? Open new tab. Yeah, so this is experiment result. So you need to look at the documentation to see how they implement this. But we know it's to really just get counts. Get count, you can get counts, but I wonder if you put results, does that give you, probably would say it's a, okay, we use results. Can we still use that? Because the result is a list. It's a list. Then we will say 0. 0 is this data. Let me see if I can get this. Yeah, so you can still, knowing that you can still get this, right? And data, maybe then you say get counts. No, it does not have this. It's almost like, at least, oh, am I, yeah. It's almost like this, right? 0, data, and then something, 0 data. Maybe we just say counts. Yeah, you can also get that. I'm just playing further. I mean, going beyond what people usually just do it and then, yeah. But here we're just printing this and then try to go through layer by layer to get the result. You can still get that. But the difference is that now it convert that to these sort of 0x representation instead of this bit string. But you can always convert. Yeah. And now this is a dictionary. So now I don't know whether you can retrieve counts by just saying this. Yeah. So you will have to use exactly 0x1 to retrieve that because it's dictionary, and then somehow they change that to this. Okay. Somehow I cannot get rid of the right panel because here, close, because it was blocked by zoom. See, actually the zoom is here, it's hiding. It's just dragging. Okay. So let me just type this again. Result simulator. And then you get okay. I don't know why in the get count you get the bit string, but when you print out the data and then access the dictionary, they give you this hex representation. Yeah, so this is, we use the sampler here, state vector sampler. This is sampler. Look again, you could also get the sampler with parameters. Like you have circuit and you have parameter. We have gone through this last time, but we just go through again. So you have the circuit that you have parameter, and you define free set of parameter for this angle. To use simulator.run, then you have to assign that to this QC, the circuit. Okay, and then for a simulator, you don't need to transpile. So if you don't do this, it will also be fine. Yeah, but in general, we just put this, okay. And print out the results. So for simulator, if you don't use like symbolic QFT or something, you don't need to transpile because it knows the basic circuit. the basic gate, so you can run. So sampler, see the sampler, we still use the state vector. State vector here. So it's a V2. This is a V2 version. So for V2, you need to use these pops. Pop is a list of tuples. It's a list of tuples. So the tuple include the circuit, this is QC2, and angles. And then there's also a number of shots. You could put number of shots here. Let me just do that. And then run this. So you use tuple inside the list. Okay. If you all have same shots, then you can just do this. Okay, it will give the same results. Now it's just to read out. To read out, we already experimented a few times above. So this is the result sampler. So I print down here. Primitive result. And it's a list also, as we experimented above. So you can print 0, 1. Is it 1? Index. Okay, so this because we only have, remember, we only have one circuit, right? We only have one pop, so this range is from 0 to the number of pops you have. And then the data that you get, it will be 3 by 1 because you have 3 different angles. So when you retrieve the count, you would say the zeros angle. So zeros angle, all right, zeros angle we define here, pi over 4. You extract that by putting the number 0. Okay. And you extract pi over 3. This is pi over 2. This angle here. Pi over 4, pi over 3, pi over 2 here. You extract that. So that's why in this code here, we are doing this sampler, the result 0, and data that measure S. It counts I. I is the, what is that? Way up here, right? So somehow, so before it turns off light, it sort of warms you. Okay, so we're getting the counts. This goes to the list of angle. Okay. Yeah, so here data, we can also see if we can have like shape. Yeah, so it's tell you the shape. Okay. Okay, and I also mentioned that if you don't specify the number here, it would add up everything. It would add up. It would add up all the counts. Okay, like here. Yeah, and why do we use a measure? Because in our circuit, we use measure O. So we would need to use that. Yeah. So I won't go through this in detail, but you can define your classical register. And when you measure, you need to, if you still use measure all, then that you still use this. But if you measure qubit and then assign to the classical register, then you would use the name CR to extract that. You can't use this, but you can use CR. This is the name that you assigned. Okay, and we also, I've seen state vectors similar in a handle bit circuit measurement. Yeah, this is another example. It has two parameters, so it runs through ranges of that. So then let's now go through this again. Estimator. When you are doing the estimator, you cannot have measurement. So here I remove the final measurement. I divide the observable. The observable, I have this value, so this observable and another observable. So I have two, and okay, this is angle and observable. The estimator, the pop is circuit, observable, angles, and then the accuracy. So compare to sampler. The sampler you would have circuit, right? Parameters, and then shots. But for the pop, for the estimator's pop, you would have circuit, observable, angle, and the accuracy. Okay, so we run this, and then you read out the result. You only have one pop, so it's 0 and data expectation value. So let me see, the observable, you have two observable, three angle. So it's this is one. I'm thinking this is one observable and three angle, and this is another observable and three angles. Right, so this is, let's see. Yeah, there's three angle, right? And then two observable. But it's arranged in this way. It's observable one, observable two. Okay. Uh, okay. Yeah, so we cover this, so let's not go through this again. So we were reviewing last notebook, and I think we ended at the one that's
Can you summarize the difference between simulator and sampler and estimator?
Simulator is basically the old way. You have a circuit, and then when you simulate, then it print out the counts.
It's done in a basic.
Yeah, simulator is always on the classical. So the simulator is things that we have been doing before we introduce estimator and sampler. There's a diagram here. These are for the estimator and sampler. They call these primitive. But here it shows that you have in quantum info there's a state vector. But this is state vector is simulator, and there's also you can also have these state vector sampler, state vector estimator. Simulator, there are also other, depending where you use, like the package, this Qiskit air simulator, right? We have this air simulator to simulate the experiment. And remember, we also have uh, the memory, so you print out what it was simulating, the measurement process. The second time you get 0, 1, third time you get 1, 0, for example, right? They have other simulator, state vector, stabilizer, measure correct states, unitary. So only when it says primitive, you would have these sampler and estimator. These are the, okay.
Why do you need sampler and estimator since we can simulate it?
No, so yeah, so these are for the running on the machine. If you want to run a machine, they use they are going to change the way they run on the machine.
Sampler and estimator are
Yeah.
for
So you can regard sampler is what we have done previously for the simulator. Right? Simulator basically simulate the counts. There's also you can simulate state vector, but simulator compared to the sampler is a function.
I didn't see you specify a backend using the sampler. So what are we running the sampler?
So sampler here if you're a simulator, then you don't need to specify the backend. This is a simulator, right? This is a simulator. You could have here I was going to use the sampler, and then here I switched to the state vector sampler. So this is a V1, right? And it says this is deprecated. So that's why here we switch. Let me just put it. Switch to V2.
On what machine?
There's no machine. This is just a classical machine simulated.
But you're using a sampler.
Which one?
Like sampler is a
Sampler. This is state vector sampler. It's a simulator. It's a classical simulator that implemented sampler, this primitive base sampler, but this is V2. Yeah, if you want to run on a real machine, we talk about this one. So last time. So you import Qiskit IBM Runtime. If you are not running on machine, you just want to use your laptop to simulate, then you don't. You could also use this, but then you will say your back end will be a simulator. Okay, back end
there-
air simulator.
If you use sampler for simulating basic, it's kind of like using the simulator. That correct?
So it's true that basically sampler and estimator don't have device information.
You yeah, you would have device information. If it's simulator, you don't need to have device information. But if you are using a backend, a real backend, like here, like here, there's a backend, right? Then you will need to input when you are defining the sampler, you will need to say which backend. So I'm using, okay, I'm going to import the sampler later. Okay, so it's not important. So we saw this last time. So here, this is sampler v2. So I would say mode. It used to say backend, but they changed. So mode equal to backend. This is from imported from sampler IBM Runtime. IBM Runtime, and so that's why you need to input the backend, but you say mode, let's say. Okay, so let's do something wrong here. Sampler equal to sampler 2. We don't say anything, it will complain, right? Right, so this is not correct. It require to input this. Okay, but in the previous one, we say sampler. This is imported from primitive. So this is a different package, import sampler. So you say sampler. Okay, it's deprecated, but okay, you could also try this. Okay, we also you won't have mode equal to, for example, simulator. This not this unexpected. So this is their design, right? They design it this way. This you cannot do. It used to say backend, but this is also not there. Okay, so this is wrong. Okay, you just have to check the documentation. This is primitive. Qiskit Primitives. Okay. Estimator, sampler. Look at this. So abstract wrong. This is their method. Yeah, abstract base classes. Yeah, this is the basic, the base Python. Oh, close this. Sampler base class. So this is abstract, so you can build on top. Others can build on top. Sampler, other more advanced. If you want, you can look at the GitHub. How it implement. Okay, so how it implement. right? So this is the V1. V1 is deprecated, so let's not worry about V1. Yeah. So this is sampler. So let's look at V2. A sample return sample upon circuit output. Okay. So it does not even say like what do you need to input the argument, right? This is based on this this class ABC. So then you can look at Qiskit runtime. Okay, if you look at this runtime and then look at this primitive, let's see where primitive. Base primitive. Okay, base primitive V2. Now there is a mode. You see here mode. Here you have a mode. And optional union backend V1, V2, and session batch string none. So you could have options, right? Mode. You see the argument mode, the execution mode used to make the primary primitive query. It can be class backend if you're using a job, session if you are using we used session before, batch you're using batch. So this is a long answer to your question, but a short answer is they design that way. But if you really know Python very well, you can dig through everything and you can implement your own. But I'm trying I'm trying the best that I know. I'm not an expert in Python, but at least I know how to use it. Okay. So you cannot use that. You cannot the V2 you cannot from the Qiskit runtime. The one that we were seeing is the primitive. We did we close that? Yeah, we closed that. It's yeah, but that's short answer is okay. So then we have the circuit. This is a simple circuit. We measure all, and there are also another one. So remember that time we did one simple circuit, one 2-qubit circuit with parameter, and their parameter. These are the angles. The circuit has two parameters, so you have three set of these. Okay, Air, you don't need to really transpile. Okay. Preset manager. Yeah, so here is already transpile, but somehow the author of this book just introduced the preset manager, so you can use that to transpile. So, okay. So we already did that here, but it's doing that again. And the to transpile, you put this target equal to target. The target is an instruction that the backend, or maybe this is for the simulator, that can accept the instruction that it understands. Brisbane, we use Brisbane to transpile. We could also use preset manager. We could also, for that, you could also use here the generate preset manager, and then we can just say Brisbane, and then also this is also the backend optimization level, etc. Okay, we skip this one. Okay, and transpile another circuit. And the way you run is you already have sampler defined. Right, this sampler underline air I defined earlier. So I'm just going back again. It's defined here, and use the sampler v2 and say mo equal to backend air. And the sampler v2 is imported from IBM Qiskit Runtime. Okay. Yeah, if you forget, then just use the code that already existed, that you know it's working. So you run this. So here, remember, for sampler, you need to say circuit, and if you have parameter, you would, the second argument is the parameter. If you don't have parameter, then you put none. This is number of shots, and like here. So you can have separate number of shots. Unless you want to have the same number of shots, you can write outside. If they have the same number of shots, like 2000, then you don't need the third one. You write here, shots equal to something, but you need to erase these numbers inside. This is not, I think, yeah, the author of this notebook and the video use Osaka, but I'm using Brisbane, so I should say Brisbane. Okay. So, and this is for the air simulator as a backend, and this is how we read out, right? So we use measure because we use measure O, and here we use C because in our circuit, quantum circuit, we define the classical register. So we define the classical register here. It's called C. So that's why you read out that. We already explained this maybe 30 minutes ago. The way to learn this is you run the code, modify the code, play with the code, and if you have exercise, do the exercise. Or we do this again and again until you everything information goes into your brain. Okay, so we will read out the result because there are two circuits, so you can have circuit 0 and circuit 1. Okay. This you don't need this, it's already there. All right, this is the second circuit. That's why I put 1 here. And I put C because the classical register has the name C. Okay, so I ran this also on Brisbane, but I'm not running again, but I'm just going to retrieve the job. So to retrieve the job, you say service. You already defined the runtime service. You say service.job and this job ID, and you can retrieve that. Okay, so I'm retrieving again. It's stored in the cloud, so you can retrieve it and plot the difference. Okay, so the simulator and yeah, the real device, they don't differ that much because that's a 1 qubit, very simple cells. Okay. And because we average over, let's see, there's only one. There's only one. But for the other one, there are 3 sets of angles. So you can bring this. I retrieve the job from Brisbane's. This is 1 because it's the second circuit. C get counts. Okay. Okay. And few don't put the number here, they will just sum up all the results. Okay. I think last time we got here. So estimator, you would define this using V2, mode equal to backend air. You might see some other codes online still use backend. This is not correct. You need to use mode. Even if you watch the video, I think the video this, let me just click. I have a link so you can just click. This is Dr. Sereno's.
We index that with number 1. Now recall from the previous video that first we need to specify the name of the sampler. We're going to know which of these 2 parameters gets, it is going to look like this, an RX gate and a control RY gate, each of parameterized circuit, and I'm going to use 2 parameters, theta and phi. And I'm also
in the old code, they say backend equal to this, but in this, the newer version, you use the mode. Okay. So that's why to teach this course, I have to constantly updating the codes, even one part. But yeah. But once I have the base material, if they don't make a bigger change, then it's probably okay. I only need to update something small. Okay, so for the estimator, you define this. Similar to sampler. So this part is very similar. But for estimator, you need to have observable because they want to estimate the observable. So this here, you see that there's a list of 2, 3 observable. Okay, so we're going to estimate these. And in estimator, this is something tricky that you have to deal with, is that once you transpile, right? Once transpile, it map the circuit to a particular qubit, right? As we showed earlier, that you map the circuit, for example, these two qubit, I assign these 2, right? So in order for your observable to be able to estimate it, you need to also transpile the observable in the sense that you need also make the correct mapping. So that's why you will say I'm calling the layout, response layout, and I need to map my observable. My observable are just XX, IY, right? These XX, IY, right? These okay, three observable. But it was defined on qubit 0 and qubit 1. You need to map according to the machine, how the machine map, right? I show you that they map to the two particular qubit. And you need to do this. You get the layout, that how it map, and you would do apply layout, observable apply layout, and this layout. So you convert that observable to that. So I print that here. The first observable is this XX plus IY. It's mapped to this string here, XX here, YY, IY, IY. IY is probably here. Yeah, because we do the transpile. When we do the transpilation, there is a logical, the abstract to the physical, right? And so you also need to map your observable to that. If you don't, then there will be error. So you need to do this one extra step. Apply layout. You could also see, let me run this. You could also print what exactly the layout is. It's a mapping, right? It's just a mapping here. It shows transpile layout. Initial layout will be layout 15. These are the two that are relevant. 15 and 22 are the two that, right? Qubit 0 in our logical is mapped to this 22. Qubit 1 is mapped to 15. All the rest, they label 0 and they call it ancilla, right? Because they are not used. And it's possible that when they transpile, they need to route that. So they will use ancilla to do the swap. But all these, you don't need to worry about the detail. You just need to supply the correct instruction right here. Okay, you just need to say I'm good, and then it will map to that. So that observable for the machine is a lot of identity, and then poly operator, right? Okay, so then you can run that. This is for the air. Let me see the air. The air, let's see the air, layout from layer. Do we have layout from the air? The air here. Okay, I don't need this. So let's print out the air to see if it. Oh. So none. For the air, there's no layout because for air, it's a simulator. It doesn't need to map to something. It still use that logical abstract, right? So you don't need to do that. But let's see, if you insist, what probably would none probably would not change anything because you would have apply. Okay, so let's just say test. Okay, so I'm going to apply layout of then this will be none, right? And see what it gets. It's not defined. I need to define. Oh, it's another the line. I need to define a empty set. Okay. So we know this is none. So it's not doing anything. Okay. And now we can run the air simulator, estimator, and we need to input this part, right? This is the circuit, observable list, angles, and you run this. And we have how many observable? We have how many observable? 3 observable. And we have how many angles? 3 angles. We remember, let's check. We have 3 angles, right? Yeah, we have 3 angles. So the output, according to what I remember, is the observable 1, angle 1, angle 2, angle 3. I could be wrong. It could be the other way around. But we have the other notebook that has 3 angle and 2 observable. It was showing 2 by 3. So this is showing 3 by 3. Okay. So that's the job the Brisbane and print the results. You can compare. This is the simulator and this is the device. Okay, this is almost 0. And this is also almost 0. This one's has a negative sign difference. Negative sign difference. So I would say the result are not so good. Advice. This one is close, but it's like 0. There's not a single one that are not good. So for example, I could say this one minus this one. So that would be the error. They are small. They are small. But because the value are already small. So if you divide it by the let's say the estimator value.
estimator while they are reliable.
Yeah, slightly more than the device. Okay. Okay. If you don't want to run on real machine, you can run on fake machine. So what you do here is import Qiskit Runtime fake provider. You import this fake Melina Melina B2. So let's do that. And according to what I have previously, you can print out the data. So you can plot error map. If I remember correctly, the function is called plot error map. Plot as backend. It's fake one. It's not defined. Maybe I didn't know. Here. Oh, because I did not load this. Okay, so this is the machine. I think it's not a big machine. Okay, there's only 5 qubit. It's a fake. So it's a simulator if you want. Okay, so you transpile and then you plot circuit layout. Plot circuit layout is not defined. Let's get that visualization. Circuit layout is the one that it shows which qubit I use. This is the 0. It shows you this is the machine and it's mapped to the 2 qubit are mapped to here. Okay, and observable, you need to apply layout. Use fake machines layout and then print the observable. This is XX, YI, XX, YI. Okay. So what are we doing now is we use session. Session, you would say when you use session, you would say backend equal to what backend, and sampler is the V2 sampler, and the mode here we would use session because we're using session. And job equal to sampler.run is machine circuit angle shots. Right? This is for the sampler and the results. You also have estimator. You could use this mode equal to session run observable angles, right? Here, the session is used so that you can actually estimate what is the next angle you want to, to achieve some optimization. Yeah, but here we are not feeding back. So it's not really, the session is actually not necessary, but you could say batch, right? I mentioned that batch is something that you don't need the classical processing. So we could just say batch. And then run this. The first circuit, yeah. If you use session, it's also okay. Was using session. But session allow you to, oh, I think I should use say batch. Batch. Because I was still using session, I just changed the but I just changed the name. Okay, batch is not defined. Let me check. I think with batch.
Backend.
With batch, backend equal to this. We don't need to say as batch.
Sample at least, I'm not sure.
But it does not say anything. Okay. But with batch, I can still define this.
Yeah, it should be. Yeah, you can also do as batch.
Yeah,
Just name for.
estimator mode. Batch is not defined. Oh,
Oh.
maybe I did not import.
Oh.
Where did I import? I think it should be here. But I don't know where I session. No, I want to find where the session is. Yeah, so I did here. So just say import. Okay, let me import later. It should still work. It's just I did not import session. Batch. Right, so it's working, yes. But you could also use session if you want to do the classical optimization. This is where you don't need the feedback. You will use batch. Okay. Okay. Let's see, I think I also upload other notebook, right? Last time. So here, I think I want to go back to the basic again. This is actually let's see. Okay, it's a series, also a series of video recorded by Derek Wang. Let me see. Qiskit learn Derek. The Wang or Wang? Yeah, so the video. And we click this introduction to Qiskit coding. So he has a few.
The point of this YouTube series is to get you up to speed with the latest developments in quantum computers for your own work.
So I have downloaded the essential notebook. You could download a notebook, I think, from the websites. You go. Did I? Okay, I did not put in a link, but you can search. So we go back to the basic, but you will see you understand everything. I hope by now you understand. So this is the first notebook. It's called, of course, Hello World. It's usually the first one. So you have, I think you now understand every line, right? Every line, you understand every line. Import on a circuit, use Adama, Sinan, okay, and output, even draw, you know what exactly. And for the operator, but you need to know where you import that. It's actually from quantum info. So these IBM programmer, they know by heart. They don't even need to look up. They know it's from which package. But for us, we just need to look up. Okay, so these are poly operator. So these will be 1, 2, 3, 4, 5, 6 observable. Optimizations. So how do I get? So there's no, this is simple. Okay, so there's no optimization. So then execute on backend. So there's use air primitive as estimator. So we estimate the observable, right? So you do the estimator dot run and circuit. This is still V1. I think it's still V1. So there's circuit times length observable and then observable. You still put circuit in the V2 version, right? You only need to have one circuit. And you put all the observable as a list. So this is the V1 version. So you can still run this, right? Okay, running this and the results. Post-processing and you just plot, okay? You plot this, okay? The line doesn't make sense. Just the dot makes sense. Okay, these are the 6 observable we have. So that is because, so this line use value, I think this is because of V1. Otherwise we use EVS. Okay, post-processing. Okay, so maybe what we could do now is change that to V2. So this is using Qiskit Air estimator. Let me see. Qiskit Air. We could use primitive state vector estimator. Let's see. Okay, so we won't go to the n qubit GZ for now, but we're going to see if we can, I mean, you can do it now. Try this exercise. This is help you understand, convert the above code to V2. That's two. V2. Right, so you could do what we have seen here. Like there's this air simulator, right? So you could use air simulator. So from the above, for example, what you could do is you can import runtime service and then use air simulator, right, as we did here. This would be one way to do that. Or you could just use state vector simulator. So previously, so there are a few different way of doing the V2 version. So it's up to you. maybe spend 5 minutes to that. I mean, we're close to the end. This will be an exercise for you. Should I put in the as the exercise for the homework? This is a simple homework, but try start it now. Try start something now. So we have from the past few code that we have, you could do that. This is sampler here we use. So as I said, you could use right. You could use state vector estimator, for example. If we do that, convert this, what we do is we will import state vector estimator. Right, and then we will define estimator to be state vector estimator. Right. And then everything is just copy and paste. Right? So you have the circuit, right? Everything you have circuit. Now you run this, except that the way you retrieve the result. So it's really just simple code. So we do this. Now the pop, right? The pop is a list of tuple. A list of tuple. So I would have a list of tuple, and I have observable, right? And I can say shots like this. See, we can, and then we run. I'm missing the bracket, right? So, oh, so we don't need shots because it's a state vector estimator, because it will be exactly evaluated. If you use air simulator, then you will need that. Okay, so now post-processing. We already have this. The only thing that you change is the value. Okay, let me copy everything. If I have an exam, midterm exam, so this will be the midterm problem. It will be just, I give you the V1 version and you modify it. Okay, here. So here, remember how do we get the results? We need to get results and then 0 dot data dot EVS. See if it works. Okay. Yeah, it worked. Right. You could also use, okay, so here I'm using, I could also use the runtime that we just have. Right? But it would be similar, right? Runtime, you could also use the runtime. V2, and then use air simulator. Use this. I could also do this. So let me add another. Well, use air simulator and estimator V2. that does not cost much. We would import this, and then we import. See, I'm just copy and paste from what we just learned for this. And then I'll define my estimator. So I just say, the backend will be a simulator, right? And then I would define the estimator. So we just have that there. Go back down. We see a sampler, and then after sampler, we do the estimator, right? So we just do this. Estimator V2. And everything is almost the same, right? So here I need to do this. I need to, okay, let me just separate these different, right? So I need to this, and here I need to specify, oh, I know what I did wrong. There's no shots, but you could input the error, right? There's no parameter. For the estimator, you would tell the error. I remember, I think that's observable less angle. This, if I say that, I would say maybe none. There's no parameter. And then this is the accuracy I want. Okay, it's running. Write it down, and I can just do this again. Right, so I'm retrieving that data EBS shows, right? This, and you could try, if I don't input any of these, what it would say. It would have some default value. Yeah. Okay. So I think for this, they probably apply some default value. You could, or maybe, I'm not sure, the state vector maybe is exact, so you don't even need to say, yeah, the error. Okay. Any questions? So I think this is a good exercise. I didn't prepare this. I just, okay, it's how you learn. You just say, okay, I want to change this, I want to do that, and see what you get. Okay, so what we'll do in the next lecture will be, we go through some of the code from Derek Wang. And you can also watch this video if you want. I think it's from IBM Qiskit Learning. If you could search that, but you could also search his, yeah. I think he has a series of video. Yeah. It's from very basic to advanced, like really run big scale job. We did this also GSZ, but mostly on the simulator. But the notebook also has implementation on the real machine. Okay. So maybe that's it for today.